Bismillahirrahmanirrahim. Dear students and audience, in this video we will talk about mitigating methane emissions from cattle through genetic selection. So climate change is real and it is a long-term change in average weather patterns that have come to define Earth's local, regional and global climates. So it's a long-term indicator of change in weather patterns. And climate change is disrupting ecosystems and food security worldwide with no mercy on livestock. So, livestock is approximately contributing more than 14% of total greenhouse gas emissions. Out of this 14%, 45 is through feed production, 6% through processing and transportation, and 10% from manures, while approximately 40% is from animal-related factors. So through selection, we can mitigate this 40% portion of livestock through genetic selection. So first step we do how we can define or measure the trait. First indicator is gross methane production, which is measured in gram per day, and it is estimated or predicted using sulfur hexafluoride SF6 as a tracer gas. What we do is we release this SF6 in human at a known rate and then measure the ratio of methane to SF6 in collected breath samples. Another indicator is methane intensity. It is the amount of methane produced per unit of milk produced. So these two, trait definitions can be used for incorporating this in genetic selection. In any case, we need to measure this gross methane production and then we can calculate methane intensity. For example, in a recent Journal of Dairy Science paper, Richardson 2021, they proposed residual methane production, phenotypically corrected for energy corrected milk, which is equal to gross methane production gram per day via SF6 tracer method. And we subtract energy corrected milk multiplied by linear regression of residual gross methane production on energy corrected milk. So this trait, which is basically a methane efficiency trait, this can be used as an indicator uh, of greenhouse gas emissions, and this can be incorporated in genetic selection. So the same authors have reported heritability of residual methane production phenotypically corrected for energy corrected milk, which is 0.21. It is a moderate estimate of heritability, implying that genetic selection can be used for directly improving methane production. Its heritability is standard error is a little bit higher. Uh, I mean, uh, and when we look at its correlation with the gross methane production, it is favorable and positive 0.89. And when we uh, look at its correlation with energy connected milk, it is negative and favorable. So these parameters suggest that directly incorporating such kind of trait in genetic selection would have a positive effect. So what breeding options we have? First option is uh, uh, first option is direct selection. For direct genetic selection against RMP, phenotypically corrected for ECM, what it would do, it would decrease methane emissions and increased energy corrected milk. Another option is indirect selection. We can select for feed efficiency, and it would indirectly reduce methane emissions. So indirect selection is a suitable way of improving this trait. Because more efficient cows tend to produce less methane per unit of feed consumed. So it is a 2022 publication which suggests that feed efficiency can be used. Another option is genomic selection. Again, here we do not need to measure methane production on a large number of cows. We will only measure it on a reference population, and then we will select animals on the basis of genotype or genotypic markers. So in this case, if we identify genomic regions associated with more or less methane production, we can use them in genomic selection. So these are the breeding options we have. Another breeding option is crossbreeding. If we have a good breed with less methane emissions, then we can use this to correct this factor in other breeds. But unfortunately, many studies suggest there is no effect of breed on methane production in cattle. So there appears to be limited scope of crossbreeding for correcting this emissions. And another study, which is a simulation study again, it claims that we can reduce methanes by 6% by crossbreeding. But again, this is due to the feed efficiency. Improved feed efficiency in crossbreds could contribute to lower methane output per unit of production. So these are the breeding options we have. And again, production system has a large impact on emissions. For example, grazing livestock, they emit more, they tend to have a higher methane production as compared to ranching, where we give high energy feed as opposed to high fiber feed in case of grazing systems. But in ranching system, we need to crucially control methane emissions from manure also. So another option is we can go for silvopasture. This is a new concept. Although it is an ancient practice, we can integrate trees and pasture into a single system of raising livestock. And pastures with trees, they sequester 5 to 10 times as much carbon as those of the same that are treeless. So pastures with trees is a solution for grazing system. So whatever emissions would be made from cattle, they would be sequestered by the trees. So recommendations from today's lecture is methane intensity can be incorporated in genetic selection program for faster gain in methane emissions in cattle. And again, indirectly, if we select for more feed efficient cattle, then it would have a positive impact on methane production. So another recommendation is we should shift the production system from pastoral or grazing to the ranching system. This can also a selection of a suitable production system in the available resources could also have a favorable impact on greenhouse gas emissions. So thank you very much for your attention. In this video, we have talked about controlling a hot area of improvement, which is controlling methane emissions from cattle. And I'm thankful for your attention. And if you have any question or feedback, you can put it in my comments. Thank you very much. Stay blessed.